Good morning, good afternoon, and good evening, depending on where you are in the RapidMiner world. My name is Graham Noseworthy, and I'm a marketing director here at RapidMiner, and I want to welcome you to today's webinar, so thank you for joining us. Today, we're going to ask a really important question, and we've got three experts on the panel who are going to help us answer it. And the question is, are you ready for modern analytics? We're going to dig right through that today, so stay tuned. Let's take a look at today's agenda. So we're going to try to just push through the opening here so we can get to the really exciting content. We're going to start by defining modern analytics. Then we're going to take a look at modern analytics as it's compared to traditional analytics, and we'll get definitions for both of those. We're going to look at the requirements, the people, the talent, the technology, the tools. We're going to take a look at some best practices and success factors. We'll go through some Q&A, and then we'll share some ways in which you can learn more. Before we get to all that, though, I want to just quickly jump through some logistics for today's webinar. So if you have a question, you can actually log your questions in the Q&A panel, which is located on the lower right-hand corner of your screen. Those questions will be addressed throughout the webinar during the Q&A section, and we'll also take care of them offline if we don't get to them during today's session. We are recording today's event, so we will provide a link to that post-event. And we'll also be archiving a version will be available on our website at rapidminer.com. We will be also producing a white paper on this, and once again, we'll go ahead and email that out to everyone after the webinar so that you have that in your hands. All right, let's get into the brain trust, the panel that we've set up here of analytics experts who are going to join us on today's webinar. I'm not going to take the time to read through the bios. You've got them on the screen in front of you, but I will just announce their names and titles. John Myers is Managing Research Director at Enterprise Management Associates. Ingo Mirswa is CEO, co-founder, and data scientist in residence here at RapidMiner. And we also have Michelle Chambers, President and Chief Operating Officer here at RapidMiner, and Michelle literally wrote the book on modern analytics, and we'll talk a little bit about that later on today. So let's dig into the definitions. Let's start off with really just understanding what this term means. So John, we'll start with you. What is modern analytics?
Well, modern analytics is a concept that I think a lot of people would probably go, hey, I've heard of this before, but it's kind of a redoing of some of the concepts that we've had over the past couple of years. If we look at some of the technical drivers that go with, what is driving the concept of modern analytics is that organizations need to move faster and get greater use out of the information that they have and being able to take those analytics together. And they're also presented with a large number of new data sources. So we're not just talking about structured data that we had from the past that we might have from a historical perspective. We're looking at multi-structured data, operational data, things of that nature, sensor data that all comes together and needs to be presented in much more of a real-time presentation layer, if you will. I like to call some of the examples of modern analytics to be things like fraud management, risk management types of activities where if you're using a much more historical look at things, you're going to miss opportunities or you're going to be overexposed in your business. And you're going to need to be able to say, hey, how do we work these workloads in so that we can bring them into our operational processes?
So John, there's a very large set of data types and a very wide range of use cases. So let's switch over to Ingo. Ingo, same question for you. What is modern analytics?
Well, I would actually like to pick it up from the data types, because I think one of the biggest differences also to traditional analytics here is that those data types are really brought together. So you're breaking down the silos, you're actually working on the different data sources, and that is really literally now we are working on the data sources. So we have somewhere else. So that is very complex, and actually generations of computer scientists spent a lot of thinking how to overcome this kind of problems, because it's really not a trivial problem which can be easily solved. It's very difficult to make this accessible to people and give people this power into their hands to push down the computation to the data sources and then consolidate all the results those analytical results in a meaningful way again. It's only the result of the past 2-3 years that we actually have been coming much closer to this goal and have been able to do this, especially in full code-free environments.
I like that. Modern analytics is accessible to the people. I think that's a great point to make. Michelle, same question. What's modern analytics?
So for me, modern analytics is really about starting with the business value and making sure that you're leveraging all of your data and that you're infusing those analytic insights into the frontline applications so that people don't have to go to a separate system and look at a scorecard or a dashboard or some kind of visualization that's really offline. It's really about having it embedded into. If you're in Salesforce and you want to know what the churn is for customers, seeing the churn right there in Salesforce and knowing what specific actions to take to mitigate the churn in the potential in your customer base. So to me, it's all about driving the business value. Modern analytics is also about really having a very agile approach, and that agile approach is a lot about experimentation and collaboration between the business and between the folks that are building your modern analytics. Because if you don't have that kind of collaborative approach where you can go very fast experiment cycle, you wind up with, in the traditional space, it would take 18 to 36 months to move something from a prototype into a production application, and that's no longer acceptable. Everything is got to be Google fast and Google easy, and so that's what you see happening with modern analytics. It is all about predictive and prescriptive, as John alluded to, which is moving to, you have to have predictive capabilities not only in one specialty area in your operations, but kind of infused throughout the organization. And it's really about being production ready, getting the value out. That's where the rubber hits the road, if you will.
Yeah, sure. So really the idea of business value, agility, collaboration, and let's be honest, doing something in 18 to 36 months is so 2005, so I think we're a little past that. Let's dig in a little bit now to some of your research, John. So I'd love to hear how modern analytics compares to traditional analytics, and maybe if you can just give us a little bit of a definition as well on the traditional side.
Well, I think traditional analytics is kind of, I don't want to call it the flip side of all the things that we've talked about, but we've talked about some of those key drivers of modern analytics are things that are going to be a part of our business processes in our organizations. Traditional analytics, a lot of times when we did predictive or we did other types of, descriptive types of analytics, there was a back office with our data scientists or our statisticians who were doing work kind of on their time frame and on their timeline, and then they would, bring it out every once in a while to a very small group of people. And, that's why I think that, some of the computations that we have in our modern analytics are very similar to what we used to have in traditional, but the speed and the pace at which we bring them to our audience increases exponentially and becomes really that analytics for the masses. So in my mind, traditional has always kind of been that back office, historical view, kind of almost mad scientist type of thing that's going on. And modern analytics is the ability to say, let's take some of those exact same processing algorithms to things that are being used by our frontline employees every single day, like cross-sell, upsell. Again, fraud management is an excellent one. You don't want to be allowing fraudsters into your customer base. How do we assess our liquidity risk from a financial services perspective? How do we bring those into our everyday lives and then have them move forward into a much wider base of people?
That's great. So we want to move from the mad scientist to the front line. I like that. Michelle?
So for me, the difference really is around traditional analytics was a lot of ad hoc analytics. So if you talk with people, not only was it backward looking, but it was a lot of give me information that responds to an inquiry that my boss or my boss's boss had. And it wasn't about moving into that production environment. And so for me, modern analytics is a lot about eliminating that chasm from ad hoc to production ready type of analytics.
I would just like to add something to this, because I think this really changed also the way how people behave and act themselves. And maybe we cover this a little bit later in this webinar today as well, but just think about this. We always talk about decision support systems, this type of ad hoc analysis where you look at data in a beautiful visualized way. But if it's data from the past, you can only build your own gut feeling and then you make some decisions. But that's not very efficient. So people change their behavior now by actually saying like, okay, if we can take predictive analytics and if we can like create millions of those, what we often call micro predictions, we can even automate to some degree those decisions and only let people focus on the really difficult tasks instead of those everyday problems, which can be fully automated in a much better way than it used to be before. So it changes the behavior of people and how they are thinking about this as well, and I think that's very exciting. And this is something, for example, traditional BI reporting, OLAP, didn't really do. It was helping people coming to decisions, but it didn't really change the way how people are acting. So.
Yeah, and I'd add to that, which is when you are making those micro decisions so that people can act on them in real time, that means that the accuracy of your model has to be very good. And it's not just accuracy in terms of, a lot of times people measure their model accuracy, but garbage in, garbage out. So you have to have attacked the data blending problem and really cleaned up your data in a way so that you get accurate results. And so, Ingo, you use the analogy of making decisions about life-threatening. So tell us a little bit about that, because that's where I think the micro-decisions and the credibility of the data is huge.
Oh, absolutely. Just think about, let's say, applications in medical domains. Let's say you're giving a recommendation. If this is a picture of a patient, for example, and then you need to make the decision, this small spot here, this might be cancer or maybe not. So now think about model accuracy, and if this model is not really 100% accurate, I wouldn't like the idea that this is an automated process where some machine makes the decision if I'm getting a treatment, yes or no. But on the other hand, an error is costly on both sides. If not, I'm not getting any treatment, although I should get it, that's not really good. But on the other hand, if I'm getting a treatment, although I don't need it, that's actually even worse, or might be even worse in the sense of like, okay, this is really a situation where I'm getting all the other effects of the drugs, or it's also just, frankly, it might actually make me ill, although I wasn't ill before. So this is really a situation where I say like, okay, if the model is 100% confident, go with the automated case. But if it's not, help a doctor, help somebody with the domain experience, pointing out the right points to like place on this medical image to look at, and really make this part of the overall. Well, when I say business process in this context sounds a little bit weird, but it's exactly what it is. Make it part of this overall process, how to assess this. So data blending, data quality, model accuracy, those are things which need to be well measured first of all, and then of course we also need a higher accuracy. Otherwise, I wouldn't be able to trust such a system at all.
So Ingo, I think you make an excellent point. I mean, your example about medical cases and things of that nature is excellent. I think there's also that point from a commerce perspective. If you start making the wrong type of cross-sell, upsell recommendations in this era, that it's very easy to move from one service provider to the next. You go, hey, these people just don't understand me, and I'm going to move on to the next group who does have a much more effective way of taking a look at it. And I think we've seen a lot of organizations who've taken this idea and said, let's get down to that micro segmenting or that micro decision that it says, hey, we are in tune with what our customers are doing. They have a great experience, and then they start telling people about it, and becomes this kind of virtuous circle, if you will. But that's all based on being able to take multiple types of data, apply it to a particular customer in real time, and make them feel good about their experience. You gave a great one about medical, but it extends over into commerce as well as into healthcare.
Fully agreed.
Absolutely. Not to mention entire industries like the ad tech industry, which built up in the past decade, which is all around using data and analytics to target people with the right ads to make sure that the optimal spend is there for marketers and advertisers. So, all right, let's get into the requirements a little bit. So, Michelle, what are the requirements for modern analytics?
So, some pretty basic requirements from analytics are that you have to be able to deal with the multiple compute engines, as Ingo alluded to earlier. What that really means is that there is no one single answer today. It really depends on your environment in terms of your enterprise and IT landscape, and it also depends on what it is that you're trying to do. So there are times when you absolutely want to run your analytics in memory because nothing will outperform that. There are times you're going to need to push the computation down to the data, as Ingo described earlier, with pushing down into distributed backends, whether it's Hadoop or whether it's a clustered environment. So you've got to have the ability to do that. You also need to have the ability to run real-time analytics. So you can't just do everything in batch processes. You've got to have the ability to do streaming type of analytics. And then cloud has become an absolutely critical and growing proportion of the requirements as well, because you're not always going to have, as you're building a model, the equipment on site, on premise, in order to build out a large-scale big data model. And so you need to have the ability to have elastic compute environments where you can push computation up to the cloud. And that really is important as you experiment, too, because if you're going to run large-scale simulations, you're probably not going to size your equipment on premise to handle all those large-scale simulations. So cloud is another really key component. The other thing is, it's not, so we talk about big data, and really I like to use the phrase all data, because all data is, it's not just structured and unstructured, but it's text, it's images, it's documents, it's even binary information, and really utilizing that, take even traditional analytic use cases and now infuse them with new rich data sources so that you actually get additional value out of your analytic insights. And so those are some of the requirements that I see really in the modern analytics landscape.
Well, Graham, actually I would like to cite you because you have been the one person who told me the story once about there are always three things: technology, tools, and talents. And you made a great point about this huge cargo ship, which can be built, whatever, for, I don't know, $50 million within a year. But who's actually running the ship? The captain, whoever that is. Actually, this person has like 30 years of experience. So it's not just like the technology and the tools. And sure, RapidMiner has been coming a long way supporting all those different computation engines, in memory, in database, in Hadoop. But it's also how do we really empower the people, the analysts actually using this. And to cite another well-known research, the one of McKinsey a couple of years ago, which stated like, okay, we are missing really like 200,000 very well data scientists by 2018, and in total I think it was like 1.8 million people with really the understanding of how to analyze data and interpret this also from the business side. This is a massive amount. You have a shortage of 1.8 million people who really need those skills, but we don't have them. So the requirements, one could think like, do we really need like those great teams of data scientists for everything? Well, my point of view is, if you have a data scientist, perfect. But for many problems, this person with this very, very difficult skill set is almost overkill. It's almost too much. For table stakes, and a lot of this is table stakes. It's not like fraud detection has never been solved by anybody before. Cross-selling, upselling, those are problem types. Those are use cases which are new maybe for your company, but they're not new in general. Cross-selling has been invented like in the mid of the 90s from a scientific perspective. So let's get serious about this and say like, let's use those very, very rare resources, those data scientists, on problems where we really need to create a new algorithm for a complete new problem, but then let's empower everybody else to use, well, this type of modern analytics, those different compute infrastructures in a much easier way. And this is a change we can see only happening now. And that's great, because the demand for modern analytics is there, and the technology is actually also there. So now people need to embrace this change and say like, okay, cool, let's get it up and running and become a captain of this huge cargo ship, but not within a year or 30 years, but actually within a couple of days.
So then let's talk a little bit more about some of these people. So we need to understand what does this mean for the people involved. So John, can you talk to us a little bit about that, maybe a little bit about the data consumer side of this as well?
Yeah, no, it's interesting. A lot of the types of projects that we've talked about, we look at them in terms of who are the end data consumers of these projects. And we've talked about data scientists and statisticians and things of that nature. EMA research has shown that a majority of the people that are the end data users of these projects are people from the line of business, whether it be a line of business executive or a business analyst, people who are less affluent with, I like to call them the knobs, if you will, of predictive analytics. But if you provide them with the background of how these decisions have been come to and things of that nature, they feel very comfortable using them in their everyday lives. I think we've talked about it before, that making them less scary. I mean, we don't need to necessarily say, hey, you need to go roll your own model to use this information and have it work out. What you have available to you is that ability to say, we've done this, we've given you a lot of confidence in what we have in terms of these models from an executive level for strategic decision making, or frontline employees from a tactical or an operational decision making process, but really have those people be a part of that. Now, that's not to say that our more technical analysts, whether it be data scientists or DBAs and things of that nature, aren't involved as the data consumers of these projects. But since they are so few and they are relatively expensive, as we've talked about, let's have them focused on those big picture projects and have these lower result types of concepts be made available to people who are on the front lines or are those business stakeholders.
And Michelle?
I like to distinguish between those that build the models and then those that actually consume the information. So from the consumption side, that should be in the frontline operational people. So that means your salespeople, your marketing folks, your researchers, whatever the different roles are in your organization, they should be seeing these insights and recommendations in their native environment, and it should be dead simple for them to understand it. They don't have to understand the model and its complexities. They just need credibility in the actual recommendations grows over a period of time. And so you have to typically start out relatively small, and then you can start moving. So in that way, what I mean is more along the predictive front, and then you can start moving into optimization, which really fits into the prescriptive front. You can do more forecasting and more optimization, but you've got to give them something that they can get their heads around and feel confident in, and then they start trusting it. It's just like when Amazon first made recommendations. I don't know about you, but I'm old enough to remember that, and sometimes I'd laugh out loud at the recommendations because they really weren't all that trustworthy, right? They weren't credible. But over time, it was almost scary how close they are today, aligned with my interests and my goals, because I've gained trust and credibility in that. If we look at the people that actually build analytic applications, people talk about data scientists as though they're sort of one ilk, one breed. And what I find is that I break down data scientists into two different types. I think of there's data scientists that are the developer type of data scientists. And those folks are very comfortable with coding and writing their own and rolling their own applications, as John mentioned. And then there's what I call the applied data scientists. And the applied data scientists use the tens of thousands of algorithms that have been invented over a long period of time. And what they know is they know their business and the business problem they're trying to solve. And what they know is they know how to put together those algorithms in a way that solves that particular problem and meets or exceeds the target or objective that they're chasing after. So if they're looking for lift, or if they're looking for a particular revenue or yield optimization, they know how to solve the problem with that. So that's traditionally what you thought about when it comes to advanced analytics. And what you see unfolding is what I would describe as the next generation business analyst. And those next generation business analysts, there's advanced business analysts today, and those typically have some data capability. They typically know their business. And then you have, when I think we know that we've achieved everything we want to in modern analytics, is when we finally empower the MBA type of business analyst. So somebody who comes straight out of business school and who can do some pretty advanced analytics, that's when I think we'll know that we've really gone mainstream with advanced analytics and predictive analytics.
Okay. So John, can you talk to us a little bit about some of the necessary technologies that are required for modern analytics?
Well, I think we've talked a little bit about data sources and all these different components, but I think some of the technologies that we need to understand are that we need to look at not just one platform or one data management area, but we need to look at a wide range of them. The EMA hybrid data ecosystem is a great example of how you bring information from data warehouses, do NoSQL, you bring them all together into a single environment, and then you're able to serve these different customer bases or these data consumer bases, as we just talked about, with all of this information. EMA's got some great information associated with how organizations are looking at not just, say, sensor data that might tell us about who's been on our website, what mobile app is being used, etc., but how do we put the context of a particular customer, of a particular product together? And that shows the value of bringing those things from different platforms, those different data sources from different platforms together. And then another part of it is how do we manage the different workloads associated with that? How do we pick the right platform that's going to get us the speed of response that we're looking for? Let's not say put all of these real-time result sets that we want on a system that is more batch-oriented, but instead let's make sure that it is presented in a platform that allows us to meet the response, the speed of response that these data consumers are looking for.
Ingo? Well, I think that's all spot on, and the only thing I can really add is my typical recommendation, which is think big but start small. And in so many cases, you don't really need to start like on streams right away or on a huge big data or Hadoop cluster. In many cases, the world is complex enough already, even if your data starts rather small and you build your first predictive models and you will figure out like, oh my gosh, I found something which I never knew before. So it, of course, absolutely depends on your use case. So if you are analyzing sensor data and, for example, doing predictive maintenance and your goal is to predict that a machine is going to break down at a certain point in time, there's no way around that the fact that you need to work with the sensor data, that you will handle data streams, and that a technology like Apache Storm can support you there, and then RapidMiner can be used to define those topologies for the Storm cluster. Of course, if that's your use case, there's no way around. But especially for many marketing and sales operations where data is living A, in the cloud, or B, in some nice CRM, or even already in the data warehouse, this would be overkill to start with that. Seriously, I would start with a very flexible platform. Make sure that all your data preparation, your data blending is done inside of this platform, because it makes a difference between traditional ETL and what I often call analytical ETL. And what I mean by this is really a certain kind of ETL, which is not just moving data from A to B, although this is also important, but it actually transforms the data in a way so that predictive models can be more easily built on top of this data. So, for example, if you're using, just to make an example, Salesforce, the data already is living in the cloud. So the only thing you really need to do is having a connector to a system like Salesforce, where you get all the customer data, in many cases even the transactions or other information about your prospects or customers, and you start analyzing this, and you would be surprised how much you can already find about that. And then you add the next data source. Let's say you're connecting this to your ERP system. Might be SAP, might be something else, doesn't really matter. And you get more insight into the customer transactions. And so that's what I meant before. Like, you have this big picture of solving every problem with predictive analytics, and you should have this picture. But then you start with one data source, and you add more and more data source, more and more systems, and this whole thing can grow over time. But again, it depends on the business case and the use case you're really solving if you have this luxury of starting small.
Sure, sure. And I've got an 8-year-old at home who's starting on his Raspberry Pi. Now that is small data, but I'm looking forward to seeing what he can do.
And you know that RapidMiner runs on your Raspberry Pi, don't you?
I do, and I am planning on putting it on there.
We're going to make him the total geek.
I know. Well, I want him to do predictive maintenance on my Nissan Altima. So, Michelle, we actually had a question come in from the audience. So what is next after machine learning? So what can we just get that question answered?
Sure. So I think about it as deep learning, and deep learning is the next set of techniques that are out there that are trying to really move closer to artificial intelligence, which is really where the analytics field started to a large degree. And so you see a lot, and the reason deep learning techniques have become popular now is because of the large distributed compute engines that are available. So it allows you to do iterative computational processing on some algorithms.
Well, Michelle, I have to disagree to some degree. So I think you have been spot on the point. Things are moving back a little bit more to artificial intelligence and to the original reasons why we actually started with machine learning. But I don't agree that deep learning is really the next big thing. And the reason why I don't agree to this part is not because deep learning is not important, because it is. But it's just one form of machine learning. It's actually not even a very new one as well. So think about deep learning as not just training a model, but also figuring out what is the best representation of data for this model. So that was the original name for deep learning, like representation learning. And in fact, every multi-layer neural network, and this is decades old, is a deep learning method. Figuring out what's the right kernel function for support vector machine. And sorry if you're not familiar, dear listeners, to support vector machines and stuff like that. I think we could do a webinar alone on this one. But they are all forms of deep learning. So I think this is just sort of an evolution, but I don't think this is the next revolutionary step. But coming back to the one comment you made on going back to artificial intelligence, let's keep in mind when this whole thing started with machine learning, people had this vision of using robotics and making robots learn, because people understood this is the only way to really learn, like to behave like a human, have a true artificial intelligence, is having something which has a body and let this thing make experiences and learn from that. And yeah,
so a very organic approach.
Oh yeah,
like humans, right?
Absolutely. So and this was really the original idea why machine learning was born. But there's one aspect. There's a connection to the real world, and I see the same thing happening right now around Internet of Things. We talked about sensor data already, bringing machine learning closer to the real world again. And I think this is going to be the next big thing in machine learning or after machine learning. It's going back to this original roots of artificial intelligence and actually bringing or connecting machine learning to the real world and having real smart objects everywhere and acting in a smart way in an autonomous way on their own. I think this is really what we can expect. I don't know the name for that, because if I know the name already for this, then, well, it's not really the next big thing.
I just want machine learning to do my laundry. All right, so let's dig into some best practices. So the number one question that we want to start with is, how do we break down data silos? John?
Well, I think that the main thing that you need to do is understand that there's not one platform that can do all the things that you're talking about. And I also think there's not just one implementation avenue. Understanding where cloud fits into your environment for both structured and multi-structured data for storage, as well as the processing avenues available to you. So to be able to break outside of the box and say, no, we're not just looking inside of our data center or on one platform within our data center, but to say, how are all of these platforms that we have available to us and these implementation engines available to us, how do we make those? So that's the one thing that I think is most important in terms of how do you break down those walls, is to really look outside of the box that you're in.
Look outside the box you're in. That's good. I like that. Michelle, same question.
So what I see is that people in their organizations tend to get siloed because of the systems that they put their data into. So if I have some data in Hadoop and some in a traditional data warehouse and some of it in the cloud, those become barriers that really prevent me from mixing the data together in one way. So I think we tend to think about starting with the data, but if we start with the business problem and then figure out what data do we need, we can usually get there from here, right? But if we start with the data to begin with, then I think we wind up constraining and living inside that box. We create our own boundary to live inside that box. Where if you think about starting with what it is that you're trying to accomplish independent of the box, then all of a sudden you actually break down the data silos, because you'll figure out some way, if it really is valuable, you're going to figure out how to bring all the data together. And any kind of platforms that allow you to blend and integrate that data to really deal with getting from multiple data sources, making it dead simple, will help to facilitate that process. So RapidMiner does, in the 10 years I've been working in this field, I have never seen a product that does it simpler, really, than RapidMiner does. I mean, because you just connect to so many different data sources. And that's the kind of platforms and tools that you need in order to really break down the data silos, in my opinion.
So Ingo, how do we make modern analytics repeatable, scalable? I mean, how do you do that?
And I think this is for me one of the big key questions around modern analytics.
Yeah.
Of course, it's also one of the biggest problems and challenges people have all the day long.
Yep.
So I think the first thing is we should stop redoing things from scratch. And unfortunately, if you're following a more traditional data science approach and coding things in R or other programming languages like Python, etc., it's just the nature of the game that you build everything anew from scratch every single time you need to solve a problem. Because there's no standard, there's no platform, there's nothing you can actually build on top of. So I think this is important, and the outcome of this is also that you create best practices by doing so. So by standardizing certain steps, you can actually create those best practices, extract them, and use them and make them available to other people as well. By the way, the idea of wisdom of crowds we're doing in RapidMiner, I'm not sure if you're familiar with this. This is really exactly this idea of collecting all the best practices in analytics and make suggestions like recommendations to all the users to learn from that, and not so reducing the need to reinvent the wheel every time anew. Another point we quickly mentioned before was around deployments, and there's no point in really having the need for 18 to 36 months after you created a model and solution that you need another 18 to 36 months for deploying it. This is really not feasible in the first place. People don't want to wait for this result. And also, if this is really the time it takes, the cost associated with this is too high. So we need to take care of this and make sure that it's only one step after you created a model for also deploying it and delivering the predictions into the usual work environments of all the employees. So, and if you think about those things along those lines, you will realize that I constantly think about how can we remove this data science bottleneck. How can we empower different people doing so? I mentioned this before. And also, last but not least, how can we encourage people to collaborate, share their results with others, build complete analytical solutions like a template, like a blueprint, so it can be used by everybody else, and speed up things from there.
So Inga, we also got a question that came in for you from the audience. So the question they're asking is basically, how do I achieve value from modern analytics if the data and the events and the model, if everything's just constantly changing?
Yeah. Actually, it's interesting. So first of all, that's the reason why we're using machine learning predictive analytics in the first place. It's adaptive. So if the world changes, the data changes, and the underlying data-generating processes change as well. So and that's the beauty about machine learning, because it's supposed to adapt to new situations and actually generalize from that and be able to extract predictions from that in the first place. But there are actually specific techniques. We call this like concept shift detection, or sometimes concept drift detection, where you see that your model you built is no longer working because it doesn't accurately describe the real world. And whenever you detect something like that, so the world changes, not the model stays actually constant or adapts to some degree, but the world changes so drastically that the model is no longer good enough for describing the real world. So that can happen slowly, then it's a concept drift, or pretty much abrupt, which is a concept shift, like an economic downtime, like we have seen this in a couple of years ago. If you detect something like that, this is value on its own. So sometimes I think like, well, let's not act like the correct model is valuable alone, and the fact that the model is no longer correct has no value whatsoever. No, the fact that you can actually detect that the world has changed, your model is no longer accurate, you need to remodel your predictive models according to the change in the world, is giving you big hints that you need to adapt and you need to make changes to actually continue to create value. And this is a huge value on itself, I think.
So change is good. Analytics is an iterative process, and the more you do it, the better it gets.
I think that's a perfect statement.
So let's take a look at just one more of these best practices and success factors. So John, I'm going to come back to you. How do we innovate with modern analytics to drive business value? And business value is really where this conversation started, and it's tied to the definition itself. So we've got to understand, how do we innovate through that?
Well, I think one of the best ways to do this is to directly tie some of the things that you're doing to, either top-line revenue, costs that help us to improve our margins, things of that nature. So to really put it into the context of business value. Sometimes it can be great for us to determine the most effective characteristics of our ideal customer, but I think it's much more effective to link, those cross-sell, upsell types of opportunities that say, hey, this is how we can improve our revenues, improve our share of wallet, things of that nature. And EMA research is showing that a lot of organizations are doing that type of work to say, when we engage in this type of project work, we're looking at ways that we can link directly to our revenues, our costs, our margins, et cetera. And that's one of the best ways that I've found that people can achieve that business value, is to link it to concepts that make sense.
Michelle?
So what I would tell people to do to look for innovative use cases is to go out and look outside of their industry, because oftentimes you can't see the forest for the trees when you're inside your own industry. So go to other industry conferences, look at, read research on other industries and see and understand how they're using analytics, and then figure out what are the analogies to your business and your specific industry. So people used to look at financial services because there were a lot of quants in financial services, and they were really on the leading edge of analytics for many, many, many years. Today, I would say your background, Graham, in digital media, they're really, as far as an industry goes, they're on the forefront. They really have done some very innovative things around analytics. And so if you look at those and figure out how does that apply to your business and your industry, that's really good. And then a little of what Ingo mentioned with the Internet of Things. You're seeing a whole new wave of innovation coming out of using sensors and the Internet of Things when you look at both on the consumer side around wearables technology, as well as on the industrialized side, where it's being used in the energy industry, where it's being used in-line in manufacturing facilities. So you see a lot of innovation coming out of there, so you can learn a lot there. So number one, look outside of your industry. The second thing that you do, and this is a shameless plug for the book, Modern Analytics and Driving Business Value, is really to create an analytic roadmap for your organization, because in the hundreds of customers that I've talked with over the years, what I have found is that analytics tends to still be fairly narrowly defined in an organization, and no matter what function, what area of the business, what line of business, analytics applies to everything any business I've ever talked with does, whether they're not-for-profit, whether they're for-profit, whether they're government agency, whether they're commercial, it doesn't really matter. And so the only way to systematically infuse analytics into your organization is to create a roadmap where you understand how it applies into the different functional areas, where it has strategic value, where it has managerial or tactical value, and where it can be used on a day-to-day execution perspective. And in the book, I give you literally the formula on how to actually create a roadmap for your organization, and then how to create a decision model. There's an example decision model so that you can prioritize and figure what works within your budget. But that's the way I think you go about innovating, is you start thinking about your business problems and how it applies, and then you'll find out how to apply this technology in new and innovative ways.
Excellent. So at this point, we're going to go into the Q&A section of today's webinar. And I want to remind you that you can log your questions in the Q&A panel located on the lower right corner of your screen. And the questions will be addressed by our panel here, but also we'll take some of them offline if we don't have a chance to get to your question today. Michelle, what application fields can we use with modern analytics?
So applications are in every industry, in every single field that you see. So it's everything from oil and gas to financial services, retail, digital media, you name it, engineering, any field that you can think of, you can use modern analytics in. And it's no longer constricted to back office type of operations, to a specialty group. It is anywhere and everywhere that you can use modern analytics today.
So wherever there's data, there's modern analytics.
Yes, sir.
All right. Ingo, how do you suggest a business analyst get started building out modern analytics models? Are there some basic rules or analysis process? I mean, what do they do?
Yeah, well, there's always this thinking about the CRISP model, etc., for predictive analytics, and it has some value, but I think in general it's actually much simpler. You only have to answer really two questions. The first question is about the time. Are you looking to the data from the past to actually make statements about the past? In that case, you really should stick to BI reporting, everything a little bit more traditional on this side. Or are you actually using the data from the past to make forecasts and predictions about the future? And then we are entering this realm of predictive analytics and data mining. So that's the first question. And you would be surprised how many people, especially if they start, get confused by that and then try to use predictive analytics for creating a report or trying to build reports in order to predict the future. Both is not really going a long way. So after you identified, and that's the second question now, after you identify that you're actually really looking to the future and that you're making predictions, it's rather simple, because you take your business problem and you put this into 4 different buckets, which are called classification, regression, clustering, and association rules. And without going into the technical details, but actually only 4. So you need to learn 4 basic concepts of modern analytics, and then you look into your business problems. And after you train this for a little, you're very efficient by taking the business problem, putting this into this bucket, and have a starting point, and then you can design those processes and take it from there, and it can usually be done within a couple of minutes.
All right, great. And Ingo, we've had another question come in, and again, this one is for you. So the question was, Ingo, how can real-time data preparation, model training, and more be done in RapidMiner?
So focus on real time, I assume. So
yeah.
In general. Well, let me very quickly say one sentence in general. So everything is code-free. It's really literally like you're standing in front of a whiteboard and designing a process where you bring in together the different data sources. You draw all the connections between the data source, and then you drag in boxes for data preparation and modeling out of a library of around 1,500 operations. So that's what RapidMiner in general is about. So for real-time analytics, we have a new product which is called RapidMiner Streams. And RapidMiner Streams really is a product which takes the same visual metaphor, the same paradigm here, that you can design a process of what should happen, which describes what should happen with the data. And this process, this workflow, is then compiled or converted into what we call a storm topology. So Apache Storm is a technology which is created for handling of massive data streams, and you use RapidMiner as the visual front end to design those topologies or workflows. Then you push this into the Apache Storm cluster. It gets distributed across all the Storm nodes, and then the data stream is handled on Storm itself. So for the user, it feels really like designing a normal RapidMiner process, but the underlying backend, the other underlying infrastructure changes and it's using Storm. Last quick note on that, what really is nice, there are like, I don't know, maybe a couple of dozen of Storm-specific operators or building blocks which you can use, but the really exciting thing is that you can combine this with all the existing RapidMiner operators. So if you, for example, have filter operations or aggregations or things like that, you can add them to the stream handling, and they are, so to say, streamified. I'm not sure if that's actually even a word, but I hope you get the idea.
We have a new Ingoism.
We do.
Streamified.
Streamified.
Yeah.
Don't worry, Ingo. You had me at storm topology. All right. So, John, one of our last questions is actually for you. Let's talk a little bit about prototyping. So how important is prototyping in modern analytics?
Well, I think it's extremely important in modern analytics. I'm a huge fan of the concept known as fail faster. I've learned more and better lessons based on the result sets that I get back that aren't perfect than the ones that I do that are. It helps me with my process. It helps me understand the data that I have associated with it. It helps me with the business problem I'm trying to address, all those different types of things. And being able to have an agile prototyping environment allows you to go through that fail faster concept. We've talked a lot in this presentation about building confidence, being agile, things of that nature, and that really just lends right into this concept of failing faster, that as we are building up these models, it gives us that chance to iterate through and say, hey, if I tweak this a little bit, let me take a look at it. Did my performance improve? Did it disimprove? Did it stay the same? Allows us to go through that process, but as we build up these prototypes, it also helps to have that framework that Ingo has talked about, that when we reach the stage that we found whether it be good enough for today or our best model of the week or the day or whatever, then we can promote that up into our environment and have that start providing results into our organization. And then we can continue to go to the next round to say, hey, let's put something together so that we're not hoping for the perfect model that answers all questions at all times, but allows us to go through an iterative staging process, if you will, to evaluate prototypes.
All right, fail faster. That reminds me of my 9th grade home ec class. Let's wrap up the webinar today. But before we do that, Michelle, you mentioned the book. I mentioned that you literally wrote the book on this subject. So tell us a little bit about your books and where they're available and how people can get their hands on them.
So Modern Analytics Methodologies, with the subtitle of Driving Business Value, is available on Amazon, and there's 2 versions of it. There's one for traditional business folks, and it has a black cover, and then there's one that has a little bit more technical detail that's aimed at higher education markets and is used in business schools today for developing curriculums around modern analytics. And that has a blue grayish cover. So both of them are available on Amazon.
All right, great. And we can actually learn a little bit more. There's some additional books we want to call your attention to: Predictive Analytics and Data Mining, Concepts and Practice with RapidMiner, Data Mining for the Masses, and RapidMiner, Data Mining Use Cases and Business Analytics Applications. We will have the white paper, so stay tuned for that. So thank you, John, Ingo, and Michelle, for your time and your insights today. It was great to be on the webinar with you today. We will follow up with all of you via email and include a link to that paper, which I mentioned. You can also follow us on Facebook, Twitter, and YouTube. And we highly suggest you take a look at our new series called 5 Minutes with Ingo. Believe me, you want to take the time to do that. You can join us at events around the world, and you can always try us out for your free download at rapidminer.com. And we thank you for joining us today.